ANSI MH28.3 governs the design, testing, and utilization of industrial work platform systems. It is a standard developed by the Storage Manufacturers Association and approved by ANSI. And it reflects something worth understanding: why empirical testing is built into the standard's methodology, not treated as optional. Most structural standards rely on pre-qualified connections, configurations whose behavior has been established through prior research and codified into design tables. When a connection is pre-qualified, the engineer can apply published values with confidence. But industrial work platform systems often use proprietary beam-to-column connections. Those connections don't appear in pre-qualification tables. And when pre-qualification doesn't exist, you cannot simply assume the connection behaves the way a standard bolted or welded detail might. That assumption has to be replaced with something else. That is the core issue the standard is addressing. Platform performance depends on the interaction of connections, load paths, and stiffness. And in a proprietary system, those interactions aren't independently documented.
You can analyze individual components, but the system-level response, how loads transfer, where flexibility concentrates, how the frame actually moves, that behavior cannot be derived from component analysis alone. It has to be observed. This is where testing enters the methodology. The purpose of testing under MH28.3 is not to prove a product passes. It is to characterize how the system actually behaves under controlled, measurable conditions. When a connection is loaded and instrumented in a laboratory setting, you can observe stiffness, deformation patterns, and the sequence of failure. That information feeds directly into the engineering model. Without it, the model is built on assumptions that may or may not hold.
MH28.3 is the product of an industry consensus process. Engineers, manufacturers, and code authorities working together to establish a methodology that reflects how these systems actually perform. The testing requirements in the standard are not arbitrary. They reflect the recognition that some things can only be known empirically. It is important to distinguish what kind of testing the standard calls for. This is not proof load testing, loading a structure until it reaches its limit. That approach establishes capacity for a single specimen under a single set of conditions. It does not tell you much about behavior. What MH28.3 calls for is system identification testing. Cyclic loading protocols that generate moment rotation relationships. Those curves describe how the connection responds across a range of deformation, not just at a single point. That is what a structural model needs.
Testing identifies stiffness, deformation characteristics, and failure modes. That is its role. What testing does not do is assign universal capacity. Test results apply to the specific configuration tested, the specific geometry, fastener pattern, and member sizes. And test results do not replace engineering judgment. They inform it. The engineer still has to apply those results to a specific platform configuration, loading condition, and design context. MH28.3 requires that testing be conducted by an accredited laboratory, independent of the manufacturer making the claim. A proprietary assertion about how a connection performs is not the same as a measured result obtained under controlled conditions by a neutral third party. Accreditation under ISO/IEC 17025 means the laboratory's methods, equipment, and personnel have been independently assessed. The data that comes out of that process is repeatable, traceable, and defensible, which matters when that data is being used to support an engineering design. This is the underlying principle. Behavior must be demonstrated,
not asserted. Evidence and empirical data carry weight in structural engineering that an unsubstantiated claim simply cannot. When a manufacturer states that a connection performs a certain way, that is a starting point. When a laboratory measures how it performs under a defined protocol, that is the basis for an engineering decision. SMHE Structural Testing is an IAS accredited testing laboratory, accreditation number TL732, and an approved testing laboratory with the City of Los Angeles Department of Building and Safety. The testing discussed here is conducted under those accreditation frameworks. To summarize the standard's intent clearly, testing identifies behavior. It does not assign capacity. Capacity is determined by the engineer, using the behavioral data that testing provides, applied within the framework of the standard's design methodology. These are distinct steps, and the standard treats them as such. The standard's approach reflects a principle that engineers will recognize. You cannot make sound decisions about a system you don't understand. Testing is how MH28.3 establishes that understanding, for systems where analysis alone is insufficient. Engineering understanding precedes engineering decisions. That is not a constraint on design. It is the foundation of it.